Hello, everybody. It's 1 minute past 11, so let's get started. Welcome to MECLA, the Materials and Embodied Carbon Leaders Alliance. My name is Hudson Worsley. I'm the chair of MECLA from Precinct, and today we've got a fantastic session. We talk about MECLA being a do tank, and this is great evidence of that doing. We're here to talk, to give a briefing of the Guide to Low Carbon Concrete that our experts in the concrete working group have produced. I'm joining you from Gadigal country of the Eora Nation, and with all MECLA events, we recognise Indigenous ownership around the country and pay respect to elders past and present, and extend welcome to any Aboriginal and Torres Strait Islander people joining us today. Thank you. And thank you to the 400 odd registrations who expressed interest in this. Clearly, this is a document that is being well received, will be read with great interest. As chair, our secretariat has already heard from the ACT government saying, hey, can we apply this tool? Can we use it? The Victorian government, their transport people also giving the thumbs up saying, hey, this is very timely, very useful, and a lot of interest from local government as well. So really thrilled that the MECLA collaborative model is delivering. Now, as always, MECLA operates in a pre-competitive space. The ACCC has recently put out a consultation paper talking about collaboration for sustainability. The key point being we mustn't engage in any anti-competitive behaviours. So I point that out at the start of every event. It's so important. But the common good, the public interest that we are seeking to achieve, I think is writ large here. So please keep that in mind. We are recording today's event for future reference for others to check it out down the line. So be aware of that. And we want this to be interactive. After we've heard the presentation from Evan Smith, he'll be joined by panelists who've been part of developing this document, but the chat function within Zoom is very real, and we'd love to hear your comments and, well, your questions to the panelists. So we have a terrific mix. One of the things I love about MECLA is the fact that it is multidisciplinary and it's about systems thinking. The QR code's just gone up on the screen. If you'd like to have a quick look at the guide, go for that. But if I could just point out, we have Evan Smith, who will take us through the guide. He comes from a concrete supplier, but he's working with Ali Kashani, a researcher from UNSW. Nicky Jackson, I asked him, how do I best describe? He just said, look, I'm a concrete dude. I'll let him explain that, but really he's a specialist consultant with a lot of industry experience. We have Claire Tubelet from the CRC, Smartcrete CRC, so talking industry collaboration there. And then Mehdi Rabati from a contractor side, from Lendlease. So we have all parts of the value chain for this topic contributing to this fantastic paper. That's enough from me. Evan, can I hand over to you and to take us through this terrific document, where it's at and where it might go afterwards. Evan, thank you very much.
All right. Thanks a lot, Hudson. Let me just share my screen and let me know if that's not coming through or anything like that. Yeah, thanks a lot for asking us to present, Hudson. So I'll dive right into it. We've got approximately 20 minutes for the presentation. Just before we go into it, just really want to kind of start and like zoom out a little bit in the context, I guess, and like why we're having this conversation, like why MECLA is here as well. So, the construction sector has a clear mandate. By 2050, we need to be carbon neutral. And by 2030, we need to have at least a 40% reduction in the embodied carbon of the construction materials as well. On the left-hand side, there's a graph. The black line is our current global greenhouse gas emissions well. The red line is our current trajectory of all government kind of commitments and policies are implemented as well. And the blue line is where we need to get to limit global warming to 1.5 degree scenario as well. So wicked challenge and very important what happens in the next couple of years as well. So the embodied carbon of concrete, first of all, this is how you make concrete. So It's about 11% cement by weight. And then you also have aggregates, about 40%, sand, 26%, water, and then there's also some air in it as well. So the embodied carbon of concrete can be reduced by a number of ways as well. So the primary emissions is from the cement. For a general cement, it might be 80 to 90% of the global warming emissions actually coming from that 11% as well. So you can use industrial byproducts and alternative materials to reduce that. So byproducts from power stations, so fly ash, byproducts from steelworks, slag, silica fume from silicon manufacturing as well. And there's a number of other SEMs that the industry is looking to use as well. Gravel, the impact from the aggregates can be reduced by using recycled aggregates coming back from the construction demolition materials as well. Sand, natural sand can actually be replaced by manufactured sand. So it's a byproduct from the quarrying activity, some of the finer materials from crushing the coarse aggregates as well. And also water. The environmental impact can be reduced with the water by actually using recycled water. So it's quite common practice as well that a lot of the concrete batching plants actually capture the wash water from hosing the yards and the trucks and the washout, and they actually reuse it into the concrete as well. So all those things can come together to reducing the embodied carbon of concrete. So I guess why is it important to use a life cycle assessment? So life cycle assessments and environmental product declarations really look at the entire impact of a product as well. Like I like to say all the way from it coming out of the ground through the extraction, like every single material that goes into the concrete that I showed you in the last slide, all the way through as it goes through to the life cycle of the product as well. So you can see that kind of like dotted line that goes through around, and that kind of summarizes the A1 to A3 cradle to gate impact of, say, ready-mix concrete. So all of the extraction, all the electricity, the diesel that goes into it for the cement manufacturing, the fuels that are burned, and the transportation the whole way along the supply chain to make it until that concrete rolls out the gate as well is A1 to A3. So quite comprehensive. EPDs are done to international life cycle standard product category rules, and they're third-party verified, and they're all publicly available as well. So really the gold standard in life cycle assessment as well. The whole industry has like a role to play in like decarbonisation. Also, the greatest opportunities are at the start of the supply chain when it's thought about up front. Like government setting targets, clients being aware of embodied carbon, setting specification requirements, so through the design phase and then through the construction phase. As you move along, your opportunity to reduce embodied carbon is diminished. So it's very important to think about it up front and as a whole of the supply chain process as well. For concrete, I guess, there'd be 20 people all the way from like the government kind of setting targets and for clients all the way through to kind of the procurement people, all the way through to it comes through to the concrete manufacturers that are batching the concrete as well. So everyone along that supply chain has a role to play as well. Just a little bit about MECLA. So I think MECLA is great because it actually has that whole entire supply chain. It's not just the cement manufacturer, the concrete manufacturer is kind of working on it. It actually incorporates, some design efficiency we need to look at, the specifications. It's a wicked complex challenge. So that's why it's so great having everyone along the supply chain being involved in MECLA as well. So people that don't know about MECLA, hopefully you'd all be aware by now, but there's a number of working groups, and I'm from the concrete and cement working group, along with Ali and Nikki and some of the other people you'll hear from shortly in the panel discussion as well. So for our working group, about approximately 25 active members for each meeting. We meet every month as well. And as you can see, like that's a bit of a mock-up of like the membership and where they sit in the supply chain. So we've got members from government, client, contractor, all the way through to the suppliers, and then also to the R&D and CRC as well. So great makeup. We've got two objectives that we've been working on as well. The first objective is actually monthly knowledge sharing. So we actually do alternating presentations from the demand side and the supply side, and try to engage all the members in the working group as well. So that's just like a snapshot of some of the ones that we had last year. And then in addition, we've been having like facilitated group discussions as well. So kicking off, I think it was start of last year in Feb 2023, we had the group discussion about, well, what is low carbon concrete to you? Like, how is your company or clients currently defining or specifying it? How are they measuring it? what are they using as a reference case? What are they using a tender document as well, and any other resources that you're like aware of that you'd like to kind of share that, there's so much kind of happening in this space as well. And then that transitioned on to the second objective as well, like advocating on behalf of the sector for the decarbonisation as well. So that then transitioned into a sub-working group from our one, looking at defining and working on a guide for low carbon concretes while we're here today. So the low carbon concrete guide subgroup, approximately 12 members for that as well. So far, we've been meeting monthly. There's been had 10 meetings as well. So a lot of work and a lot of discussions gone into it. And as you can see, it's everyone from across the supply chain as well. It's great. I won't go through this, but just an overview of like our timeline and kind of how this guide come about. Just kind of highlight that it's a consultative process that we've gone through, developing revisions, survey, seeking format feedback as well, and kind of going through that as well. All right, so kind of moving on and just to kind of summarize some of the discussions that we've been having in the guide working group as well. So the challenge is low carbon concrete. Like, how can you define it? Like, the carbon intensity of concrete depends on like where you are, the application you're using it, the type, the strength, the material availability, and the construction needs all kind of go into like what is low carbon concrete for. Like, if you're in precast concrete, it's completely different from like footpaths as well, about like what is actually challenging, what is a low carbon for that use, or in WA, like what's a low carbon concrete for burnished floors compared to like in Queensland, we might have different availability of materials. So quite complex, a lot of discussions. We've got a lot of really knowledgeable concrete practitioners in as well. So, we're probably more, the initial discussions like, how can we kind of make it perfect and accurate and that? So it's more on the right-hand side as well. So this really kind of helped us. This is from the Global Cement and Concrete Associations. The slide came across, and this really kind of helped us and really try to form our center as well. Like, we had a lot of discussions and we're like, well, where is this kind of falling in? Is it, too simplistic at one end, and it's like can be easily understood, but it could be like meaningless and useless. And then on the other end, which is perfection and accuracy, but at the extreme end, it can be millions of different benchmarks for different applications and locations. So we're trying to center ourselves on, is this good? Like, that's what we're aiming for, middle of the road, not to seek perfection or not oversimplify it as well. So that led us to the proposed approach for the guide. We wanted, and through the survey as well, I guess we decided we wanted to be Australia-wide at first initially. So that kind of set the precedent. Australia-wide, we wanted it to be broadly for all kind of stakeholders, architects, designers, engineers, researchers, and users as well. So, that kind of thing is spectrum as well of thinking. And then to look at like existing approaches around the world and what they've kind of done and kind of learn and like leapfrog along. Was that we knew it was going to be the first iteration. We had to start somewhere as well. And yet, as I said before, we knew it wasn't going to be perfect, but we wanted it to be definitely useful. Had a lot of discussion for a lot of concrete practitioners might kind of know there's normal classes concretes and there's special classes of concrete. The special class might be 50% of the concretes that are used in Australia, but there's so many different types of uses of them, like post-tension, precast, burnish, all these things, and they're all completely different. They're not comparable. But there is also normal class concrete, which is strength at 28 days as well, and is fairly kind of comparable in the strength grades as well. So we had a discussion like, should we split that out? But then we kind of returned to center. It's like, well, for some users and architects and that, they might not even know what type of concrete they're going to kind of use yet. So like, let's try to include all of them, but note that kind of caveat as well. We also want it to be useful for a range of stakeholders as well. So we were able to get our hands on some of the EPD data that I mentioned before as well. So it's all publicly available. Initially, we started off like opening up the EPDs and getting the numbers like for all the normal class concretes. But when we decided to expand to the special class concretes, just too many now to kind of really keep up. Like, I work in the area, I still don't know what like the lowest carbon concrete is and the numbers, because there's just so many. You have to open up the PDF, look at them, kind of transcribe it down. So we've got a lot of people around Australia been looking at that as well. For the resources that we actually had a connection through Lendlease. It's one of the members of EC3. It's an online database, and they've actually been using API to like mine the EPD data around the world as well. So we were able to get our hands on that as well. So that contained over 1,200 normal and special class mixes for ready mix concrete in Australia as well. Won't go through all of the detail, but initially when we had a look at the data, like, oh, okay, there's some kind of things going on here as well. So there was a process to kind of go through and actually like clean up the data because it'd been used, API had been used to kind of mine it. There's some issues with some of the strength classifications as well, and then also some kind of minor errors as well that we picked up where we went through as well. Then that led us on to then we had the data set. Then we're able to kind of graph that out statistically. So for the first, we had a data set. Okay, well, what do we do with this data set? So then we cast our eye out to what's happening internationally. Some of the leaders in classification systems are all looking at actual data. There's 2 in the UK, so the low carbon concrete working group from the industry over there. They took an approach where had all the data from the industry and then looked at kind of dividing it up in 20% chunks. So an A might be the best in class, the top 20% of the best in class as well. And then C is your medium one as well. And then they were looking to update that every year as well. So if you bought A concrete, you always knew it was the top 20% in the UK for all types of concrete as well. There's some issues, I guess, with that approach as well, that some of the ones I mentioned before about durability application, it all kind of differs depending on what you can actually do with the concrete and what level of reduction of that. So for an example, piling, you can do a lot in that as well. Typically a low heat concrete is going to use has a lower embodied carbon, but say buildings post tension have a higher impact as well. So it doesn't kind of really look at the actual uses and the differences as well. There's another approach in the UK, come from Arup, and actually look to kind of build upon that as well. And rather than having A's and benchmarks that kind of moved over time depending on what was available, just looked at kind of having a bit of a fixed baseline. So A is 0 emissions, that's where we're aiming to be. G is the worst in class that's available there as well. And they just had 20% blocks kind of going down from that as well for a bit of a classification. And then you apply your data set over the top of that, depending on what data set you're looking at. So this might be all the concretes, or this might be, particularly just post tension as well. So you have a look at it and okay, well, what is available? Okay, best in class at the moment is maybe a C. So it's as simple as that. So then moving on, so to the actual release of it. So we kind of took all that. The guide was released in May this year as well. And since then, we've been going through a process of consultation. We've been receiving some good feedback, as Hudson mentioned. So I'll quickly take you through the guide. I think we've got maybe 5-10 minutes left as well. So I'll quickly go through that and we'll go into the panel discussion. So just to cover for it, just a brief introduction about and some links to some great resources that are available. So there has been a lot done in the sector in Australia. So there's some links through to actually the sector's decarbonisation plan as well, and also the acknowledgement of the limitations of the guide. It's not perfect, it's a start, and it's going to be a iterative process. And also that it takes all concrete together. It doesn't account for different variations and applications as well. We had a crack at a definition for low carbon concrete that, taking all those things into consideration that we just went through before, but low carbon concrete should be the lowest carbon concrete available for that specific application, but still meeting all technical and performance requirements required by the concrete, and meeting the Australian standards, which are important for durability and other requirements as well. So really working within the bounds of the current concrete, but then for each of the applications, low carbon concrete should be the lowest available for that application. That should be the aim. Some kind of general instructions for use. So, main thing is starting at the start, specifying that you need a low carbon concrete. That's often just enough to to trigger the process. If that comes through in a specification, the concrete company say, okay, yeah, we want a low carbon concrete, they'll kind of match that up and provide it. So, and as I said before, request a low carbon concrete, but it still needs to meet all these other technical requirements, like shrinkage or slump or any other specifications as well. This is just an additional performance requirement for the first time actually going, hey, we actually want, a lower carbon concrete for that application, and putting that as a performance requirement, just like anything else. Requiring an EPD, so the EPDs ensure that the entire life cycle assessment is looked at. We're there's a lot of developments now happening in the supply chain for decarbonising, and not all cements are the same. The supplementary cementitious materials have different material impacts as well. Transportations, admixtures, they all kind of go into the mix as well. So it's important you look at it all, the entire life cycle of it, and it's creditable, third-party verified data as well. And then the third one is to liaise with the supply chain and set embodied carbon targets. So and move away, like avoid setting targets based on percentage of SEM, because there's some issues with that, which we probably don't have time to go into today. Moving through, so 5 considerations. These are really kind of things that kind of come up a lot in terms of kind of questions, and then some broad principles as well. And an aim is to kind of, from everyone along the supply chain, have these kind of useful. So the number one thing, I guess, like, have you engaged with the supply chain? Like, early engagement with the supply chain helps decarbonisation of concrete. There's a great guide in there from the Green Building Council of Australia, the Practical Upfront Guide to Carbon Reduction. So actually has all the different stakeholders and what you can do in relation to embodied carbon, what you should be thinking about. The number one question normally kind of comes up is like, what is the cost of low carbon concrete? So there's some links in there to some MECLA spotlight events as well, where people will talk about low carbon concrete, but generally, like all things, like if it's thought about upfront and early, like the cost, it can be cost comparable, insignificant into the wider context of the project. However, opportunity, that we said, as you move along the product life cycle stage, get less and less as you kind of move through that. Do you need low carbon concrete? Actually, a low carbon structure. So the aim is obviously low carbon infrastructure and buildings and a total life cycle kind of thinking of it. So no use using low carbon concrete if you use twice as much of it than you kind of needed. And then just to open people's mind as well, like it's about the entire life cycle assessment as well. So sometimes you can use potentially a higher impact product. If you can use less of that, you can potentially achieve a greater reduction overall for the project as well. So really kind of think outside the box as well. The next question as well is normally like, well, I'm in a regional location, like what's kind of available? Like, so we kind of try to land on that as well. Like low carbon concrete is available in most metro and many regional locations. And, start by asking for it, engage with the supply chain. This drives demand. Like we've had some situations where, due to demand, additional silos were installed, and then you can have further reductions available in that location. And then the next question is normally like, well, what level of embodied carbon reduction is kind of possible, and what are the limitations? So generally, for normal class concretes are the largest level of reductions, and then due to the performance requirements, the special class concrete, some of their, could be less due to their performance requirements. But it really depends on the application and where you are. But one of the important things to kind of note that, overly prescriptive specification requirements can kind of limit the level of reduction. So overly ambitious cycle times or other kind of performance requirements. And then moving on to the final page as well. So this is where it all kind of comes together. So this is a graph of that data that we got from EC3. So this is all the EPD data available for ready-mix concrete in Australia, broken down by strength grades. So at the top, the red line, that's worst in class, highest impact by an EPD in Australia. And then the bottom of the box and whisker is the lowest available. And then in the middle is the medium, so that's a 50%. So, for the first time, you can kind of see, and I think this is really kind of powerful, like, accurate measurement and then data and knowledge is power. So for the first time, you can see, well, where are we actually at, in terms of the lowest carbon concrete for a 50 MPa? I've got this EPD number for it. How does it compare to like what's available? Like noting that it's all across Australia for all different types of applications, but for the first time, you kind of got that, power, and that's just going to grow as it's more and more EPDs that are coming to market as well. So, and then the tables just go through that data as well. So what's aligned for, say 50 percentile, like, so then you can start using some of the numbers that you have from EPDs and go, how does that compare to the medium or the max or the min? All right, so just final slide and just, next step. So aim is like communication of this, seeking feedback, seeking endorsement. And the next stage is really looking at getting additional EPD data as well. There was, we were up to like April last year, I think, for the data set that we could get. There's EPDs getting registered every day as well. So like seeing if we get some more data as well. And then the next stage is like looking for the breakdown by state, regional locations, and specific uses as well that I mentioned a couple of them today. All right, so I'll stop sharing now and then over to you, Hudson, to kick off the panel discussion. Hudson, can you hear me? Yeah, I think you're muted.
All right, good. Sorry, I was struggling to unmute myself. Evan, thank you. That's terrific. And I think, I mean, yes, there's a lot of technical detail, but I think the thoroughness of those who've been involved and the consultation that's gone into this means that it's, there's real validity to it because of that process. Let me invite Ali and Nikki and Claire and Mehdi to join us now. If you could pop your cameras on, great. Yes, now questions have started coming into the chat, which is fantastic. But Claire, I think you wanted to show something also to add some context. Can I ask you to share your slide?
Yeah, happy to. Let me just share screen. There we go. Oh, share. So just to kind of round out the conversation and what Evan was talking about there in terms of the need for us to get really effective data and knowledge sharing processes. This is a slide that we pulled together about a year ago based on IBIS data. So IBIS collects really it's the economic data for all sorts of different sectors across Australia. So this doesn't talk to volumes, it talks to value. But this pulls together 3 IBIS reports that look at the size of cement and lime manufacturing, cement products manufacturing, and then ready-mix concrete manufacturing. And what we've done is we've just pulled it together to show you essentially where does all the concrete go. So you're probably aware that about 29 million tonnes of concrete is used in Australia every year. And what you can see from this is that a significant amount of that concrete goes into residential buildings, a significant amount goes into non-residential commercial buildings, and then really the rest of it goes into government infrastructure. And at a very, very incorrect kind of percentage level here, you can say that roughly a third goes into each of those 3 categories. And so that's why it's been so important for MECLA to be a leader in this conversation around how we get very broad knowledge around what do we mean when we say low carbon concrete, because the sector is so diverse. We're talking about a third of this concrete going into the residential space. How do we make sure that when you're going into Bunnings or when you're talking to a subcontractor who's going to supply concrete for your driveway, how do you know the questions that you can ask in order to have a conversation about lower carbon concrete options? And so that's why this guide has been such a seminal piece, because it really helps the consumer or a participant within the supply chain for commercial or infrastructure projects to be able to ask those questions and at least start a conversation. How do I stop sharing? Stop share.
Stop share. Great. Thank you, Claire. And I think it's really, it's a really great question. Where does all the concrete go? 29 million tonnes of the stuff. That we're talking big numbers there. So that's fantastic. Hey, look, I'll throw a question to you from the chat, but ask maybe different perspectives across the group here. What targets are best? Is the direct global warming potential target appropriate? And can the market respond to that efficiently? That's from David Law. Who wants to answer that one?
Yeah, I might even kind of kick it off. I'm sure Nikki's got some thoughts on it. Like, I think you might see, like in the guide, we didn't say anything specific. There's a lot of numbers in there, but we didn't actually define it just to the complexity of like all the different kind of uses as well of like that. So I think it's about a process of kind of going through and looking at the concretes that you are using and looking at, you can go lower carbon. That's why it's important to kind of specify it up front. Like, we want the lowest carbon concrete available for our application as well. So, but the EPDs do work in absolute numbers. There are different kind of reference cases, like different projects. If you're like a Green Star project, they specify what they want as a reference case used. Kind of is like for infrastructure projects, obviously they've got lots of different types of ones. So there's, depending on what you're looking at as well, and then the Australian lifestyle, there's different things to compare it to. But the number one thing is like EPD numbers are absolute, so you can always work in absolutes, and that's what we've also seen Lang and Rourke do as well. Was setting it's like, this is our absolute limit for maximum. This is our ambition for like low carbon concrete. So the EPD numbers kind of don't change. percentages normally change depending on what you kind of compare it to. So you can work in the EPDs, I guess they don't kind of change across the board. Nikki, do you have anything to add on to that? Yes.
No, I think that's why we went round and round. I think one of the biggest discussion points for the whole guide was we were scared about specifying a number of where low carbon concrete would start, because we were so aware of the challenges that you face in Australia. You know, we're not like other countries. We're so big compared to the amount of concrete that we produce, and it's so different in different areas that what you can achieve in Victoria is going to be vastly different than what you can achieve in far north Queensland. So that's why we tried to steer away from specifying a certain number for where low carbon concrete should start, and that's why with the instructions it's about trying to engage early on with your supplier to see what's actually possible based on your requirements and your performance of the concrete, and by all means challenge them. If this is what they can do, say, okay, well, by the end of this project, can we reduce it by 10%? Is there something that we can work on while still meeting all these other performance requirements? So that's sort of why we kind of steered away from putting in an absolute number for this initial guide. That answers the question, but yes, targeting.
I think for the first time you've got like a yardstick now. So if you get a number, from your supplier or your contractor, you can kind of go, well, where does that kind of look like? It might be, your number might be really high because like you may be saying WA doing precast concrete or something, and we kind of know from the data like that's maybe some of the higher emissions, but you can kind of see, well, where do I sit on the scale of it? Am I at the kind of the lowest available for this application, or is it kind of more of the challenging? And I guess the aim what we're looking at is try and get all uses of concrete to go just that little bit further, not like it's not about like one guy using the lowest carbon concrete kind of for a bespoke application. It's about all industries, kind of all applications going, well, where do we sit in the band, and kind of can we do better than what we're currently doing as well? Because that'll have a massive effect as well. Just really shift the dial as well. We didn't want the guide to be like elitist or excluding kind of people like, oh, I'm in a regional location, their definition doesn't apply for us. We didn't want to do that at all. We wanted it to kind of engage everyone across the supply chain for concrete.
It's important. Thanks, Evan and Nikki. Mehdi, I might ask you from a contractor's point of view, you're with Lend-Lease. One of the questions is asking, well, if you ask a manufacturer for a 20% reduction in carbon from their concrete, can they do it? Do they know what you're talking about? Do they know what to do? What's your experience been?
Actually, thank you, team, and thank you all. That's a very good question. I give a little bit background of the Lend-Lease. We have an absolute target by 2040. So for us to be able to measure our progress, we need to deal with the absolute number. So, and also have a consistent, transparent approach. The way we collect the data, extract the information, feedback the information to the project team and our stakeholder. So if someone tell me in the industry, also I'm double hat, I'm a researcher as well. Like someone tell me 20%, I say 20% from where and from what? What's the base case? So having an absolute number, and that number could be shared across the team. So this guy is providing some kind of the guardrail. So it's not only true answer, but that provides a high level map of what type of concrete exists in Australia by having a last year data. We're going to update it and new data. So for me and for us, it's kind of the having transparency. And some of our client has a quite ambitious carbon target. So they put it at the B. They say, we need that kind of concrete. They don't talk about the SCM percentage. They don't talk about certain percentage of certain rating tool. They talk about global warming potential, kilogram CO2 per volume, per grade. So to me, I see that one step forward.
That's terrific. Thank you. Ali, as a researcher, what baseline are we using? If we're saying we're aiming for a 20% reduction on this project or a 30%, 20% against what?
Thank you, Hudson. I think that's one of the things that we started at MECLA Cement and Concrete Working Group since 3.5 years ago, is just shifting the mindsets that just a cement replacement, using SCM percentages, etc., to using the embodied carbon numbers, so global warming potential, carbon footprint, and as such, And we've seen since, I'm not saying like it's just because of MECLA, but I'm sure that MECLA helped a lot. But since then, we've seen a lot of transition to getting EPD. So the number of EPDs has been increased massively during the recent months or years. So it's still increasing. So this guideline is giving a very good benchmark of things that's available at the time that we made the guideline. But I think that in a couple of years, it's going to be updated, or even like in 1 year from now, it needs to be updated because, you know, the landscape is changing very fast. And if you also compare like what is available in Australia to other countries around the world, in Europe and UK, you can see that we still have a lot of room to decarbonize more the concrete that we have here. Obviously, there are other factors such as transport, etc. In Australia that is different in other jurisdictions, but there is lots of things that we can do. And the other thing that also I want to touch base is, and we also had a lot of discussion in that in our working group as well, is not only the embodied carbon of concrete that it matters, it's just about the whole project. So essentially, if we use less concrete, it's better option than using even like, you know, very low carbon concrete. So we need to look at holistically into the project, how we can reduce the embodied carbon overall. And as we know, like, you know, in some contractors, they have a benchmark to reduce, and we have the government that they want to reduce to net zero, etc. So there's lots needs to be done. Thanks.
Okay. Yeah, thank you. Hey, one of the questions talks about price. So and cost. So I'm a sustainability guy. I think this is all fantastic, but imagine I'm working on a project and, you know, some more business as usual thinking is also in the room, and they say, well, yeah, but how much does it cost? What, you know, how much is this going to change the budget? Mehdi, you're on the constructor side. That's probably a question that you get asked. Nikki, concrete guy in multiple settings. How do you respond to that? Starting with you, Mehdi.
Yeah, yes, sure. I'll talk about what we are doing at Lendlease now. What we are doing, we are creating a national concrete database. What concrete used where with which performance, as well as global warming. So when we say, because there is a code to say if carpenter tool is a hammer, everything become nails. So we need to put that on its perspective, what we need to use in which application. And to me, like that kind of the typical like normal concrete, like you shouldn't cost premium, but certain application, certain type of mixes, absolutely, because certain SCM need to be bring to Australia, it might not exist, that may have a cost premium. So so it's a very, very variation in the cost. I think in a Lane Rock, in one of the data, they say it can be changed from $4 to $30 per cube. So it depends the application, I would say.
Okay, Nikki, what's your response to that?
Yeah, I think it's the same. Depending on the application and the target reductions you're trying to achieve will vary. If you're trying to aim for like a 4 or 5% reduction on a normal cast concrete for residential, you could possibly be, you know, just a few dollars more a cubic meter. If you're looking at trying to get reductions in post-tension or precast concrete and still maintaining the same sort of cycles that you need for early age strength, you know, with the current technologies that we've got around and what we need to do to push the concrete for early age strength, you know, you could see the cost going from $30 to $50 a cubic meter just to get that same performance. Just because that's the type of technology that we have and how you need to apply them based on the volume. And I think too, the other thing, and sort of throws a curly one in there, is that as we start to see power stations get decommissioned and turned off, and we start to extract hash from dams, which happens overseas at the moment, it's happening in the US, all through Canada. There's no reason that we're not going to start here in Australia, that there's going to be a cost impact. Fly ash is not going to be the same price as what it used to be. So we're going to be able to reduce the embodied carbon, but again, that will come at a price in the future. So I think that it will change what we typically see in regards to the pricing, and that's going to be a natural evolution of the change of industry as things change. You know, as we switch to electric arc furnaces too, we can still use that type of slag compared to blast furnace, but the properties are slightly different. So we just need to change the amount that we can use. It'll affect, you know, how much reduction that we can get. And we've got new and novel SCMs coming in as well. They manufacture pozzolans. There's going to be a cost impact to those SCMs to be able to put them into concrete. So it's going to be that natural evolution of materials changing within the industry, that naturally all things are going to go up. And a part of what's going to happen, I see, is that as everything goes up and it becomes business as usual, the actual embodied carbon of concrete is going to naturally reduce over time. And it's just going to be a cycle of doing business. We're just going to have to accept that there's going to be a price increase based on the change of raw materials. I mean, we've seen excess cement price increases over the last 18 months. They've gone up considerably, which has impacted the industry. We're still producing concrete. We're still making 29 million cubic meters of concrete a year. Nothing's, it hasn't, business is still there. In fact, the businesses and the industry's grown. So the cost will be there, but I think the industry will be able to adopt it, and we'll just move on.
All right.
Hudson, I'd like to add on to it, just with the guide and then one of the links in it. I mean, there's a really great one from, I think, the city of Melbourne in there. They got asked that question, and like for their wider project, I think like they used low carbon concrete on it, and they said it was a 0.21% increase in total project cost. So like in the scheme of things of the whole construction project, like 0.21% for them to use a low carbon concrete. So I think it really depends overall on the projects and the specifics of it. Yeah, wouldn't want to kind of scare anyone off of it. And then potentially, some of those percentages that we're talking about as well, like, if we're talking about fruit, the dollars, it might be like insignificant in the overall cost of the concrete. And then maybe even, between concrete manufacturers, the price difference between might be greater than the actual difference of the lower carbon concrete. So I think it really, really depends, I think, and the specifics of it. But as you need to push in more materials and add mixtures, there's definitely increasing material costs as that.
Okay, great. Did you say 0.21%? So
0.21%. Yeah, I will share the link. Well, that's from there. So I thought that was kind of great. And for them, they looked at for the wider construction costs. So maybe it's that $3 extra per cubic meter, but then that was like 1% for their cost of their concrete, but then for their whole project for all the different materials. So I thought that was kind of a great example, and that wider kind of zoomed out kind of thinking for them and the level of carbon reduction that they got. So I think they achieved like a 38% reduction, they said. Yeah.
Okay. Yeah, be interesting to share that with the group. Nikki mentioned a couple of times about future and longer timeframes. Claire, if I could bring you in there, because I know your CRC role is also got that longer lens. What are your thoughts on future low carbon solutions?
Yeah, thanks, Hudson. I think if you think about the future for low carbon concrete, there's really three ways that we, if we sum up all of the great work that's happening in this space, there's three ways that we lower carbon in terms of a concrete product going forward. So number one is we look at reducing the carbon in terms of the production of cement. And there are some really fantastic projects that are happening in that space at the moment around transitioning the way that we calcinate limestone, for example, how we can capture that carbon and then use that carbon in all sorts of other ways. I'm sure many people on the line at the moment have heard of MCI Carbon, which is a really fantastic Australian business, really leading the charge globally in terms of how we capture carbon from the process and then reuse that. So if we can do that, then it gives us a really great opportunity to reduce the embodied carbon in the cement and therefore get a lower carbon concrete product overall. Obviously, another way to do it is to look at how we do cement replacement. And there's been a lot of discussion today about the use of supplementary cementitious materials. And there's a whole world of research that's happening at the moment about the future of supplementary cementitious materials. So thinking about new products or even the rehabilitation of things like fly ash dams or dam ash, I should say. And then the third one obviously is dematerialization. So within the context of the build, how can you use less materials to achieve the same performance in the project? So if we kind of set that one aside, because that's not really what this guide is about. This guide is about if you're using concrete, how do you get that that good understanding of what a low carbon concrete is? the way that this guide has been designed, I think really works well in terms of using that global warming potential or the embodied carbon number as the measure, because it means as we continue to get innovation in lower carbon cements through either carbon capture, use storage, or through just improvements in terms of the cement manufacturing process itself. And as we start to get concretes that have higher supplementary cementitious material percentages, we're going to be able to continue to use this guide, as Evan said, just kind of adjusting those baselines, because we're using that single number of embodied carbon or global warming potential to be able to look across them. So I think this guide is really future proofed as we continue to do really amazing research into new lower carbon concrete products.
Well, that's very reassuring to hear. Thank you, Claire. But it really does emphasize just how dynamic this is, isn't it? You know, we really do all have to stay awake and stay on top of the evolving field. Ali, as a researcher, there's a question here that I think you'll be able to answer, and it's about geopolymer concrete and, you know, as an alternative to Portland-based cement. You know, why hasn't it become more widespread? What role does it play, and where does it stand?
I think geopolymer concrete is a great option in terms of using low carbon concrete, but it's not the only solution. So we still need to see, like, in terms of the supply and demand. So how much supply of geopolymer do we have in terms of the landscape in Australia, which places we can get access to geopolymer concrete. Hopefully in the future we can see more supply of geopolymer concrete. But it's going to be part of our decarbonization journey for sure. And also any other new alternative cements that comes down the track, we need to be very swift in terms of, you know, doing demonstrations, more research, development, testing, durability, etc., in order to take up those alternatives. As well as we know, if you want to get to zero carbon concrete, so the low carbon concrete is not going to be an option. So we need to think about how we can actually make zero carbon concrete. So is very challenging, but there is lots of solutions currently being researched at the moment. Hopefully we can update those research soon.
Thank you, Ali. Keeping you and Claire very busy, I imagine, all of that research. And out of interest, one of the case studies on the MECLA resources page is a City of Sydney demonstration project using geopolymer, I think on Botany Road in Sydney, like for like, with a section of conventional road to provide that comparison. Pardon me. Another thing that's come in the questions is around, you know, are the concrete providers responding to this guide? Evan, I know you work for one of them, but you know, does Wholesome have a position about the guide? Do we know what Boral has to say? You know, how does the market respond to this piece of work? Noting that it's not to promote a company, it's to promote an understanding of how to procure this.
Yeah, well, I mean, a lot of the industry has been involved in the guide as well. So there's a number of like concrete and cement manufacturers like in the group and the subgroup as well. But I think, you know, that wider kind of industry perspective is more like a CCAA kind of comment kind of on it. But yeah, there's a lot of the industry is involved in that. And that was the aim of, like, you know, something, I guess, for everyone. So it aligns with the approach that is taken by the industry. I think someone mentioned before, like, the number of EPDs. So we've got 1,200 mixes that now are covered by EPDs, and that's really great for the supply chain and for consumers, because you've got the best data in class. It's all publicly available and it's all third party verified. So, you know, it really helps with like any kind of claims that it's like with that as well. And I think there's probably it's hard to keep track, but I think it's like 12, maybe 15 concrete manufacturers now got EPDs as well. So it's definitely the approach that the global construction sector is taking. I think there's like 90,000 EPDs for concrete in the US as well, in Europe as well. In the US and Europe, they're actually implementing legislation to require it as part of their decarbonisation strategies as well. So definitely aligned with industry approach. And I think it's the best thing for consumers as well, that, you know, this is an additional performance attribute of the concrete. You got you know, the cost of it, the quality, you know, the time for the element and his carbon into it as well. But you got a really accurate measurement of carbon as well. And then, you know, use that to drive the supply chain as well. So EPDs are great because it doesn't mean that all cements are the same. If the cement manufacturer wants to decarbonize their supply chain, use additional alternative fuels, do upgrades, and that actually rewards them as well. So it's I think it's great for the industry and for the supply chain, and helps decarbonize the sector.
Okay, terrific. All right, so it's aiding transparency there. That's really good. Hey, look, let's change gear a little bit and look at the potential downsides. Put a risk management hat on. What might I be worried about if I have to lay a slab and sustainability guy with his Birkenstocks is telling me, hey, I want to use low emission cement, and you're saying, well, you need to consider this. What are the factors that need to be on the table when you're considering a lower carbon alternative? Who can start me there? Maybe Nikki.
It's a tricky one. Probably you shouldn't really notice much of a difference. There might be some placing issues. It might be a little bit harder to screed. Depends on the workability. Depends on the type and the percentage and the type of SCM. But typically, when you're chasing a performance parameter, you're going to try and make it work the same. Like post-tension concrete, we talk about early age strength. The concrete still needs to set about the same time as what it would if it didn't have a lower embodied carbon intensity. Otherwise, you're not going to get that early age strength. You still need time for development of strength. I don't know that you're going to see, typically as a concrete mix design person, you try not to have it so obscure that it's so different. If anything, you're going to try and make it look a little bit better. You might advise people that, you know, might definitely need to be a bit more curing because it's going to have a lower strength development if you're talking like in a residential space. But typically from a setting time, we generally manage as a concrete mix design person, as though there's nothing in the standards that says there's a setting time. It's just an industry expectation that you get your concreters off before the end of the day, before the sun goes down. So you generally will design your concrete to meet that requirement. You try and keep everything as close to what it is, because that's the idea of the guide, right? Is that lower carbon concrete's got to meet all the same performance requirements of what you're trying to achieve. So if you push out the early age strength requirement to 2 days instead of 1 day, well, it's not the same concrete, right? Now you might be able to do your project cycle time, but technically it's not the same concrete. So you shouldn't really see much of an issue, I would say, in regards to placing it on site. Other than just some extra care with curing, I would say, when you get to higher or lower cement levels and you get that lower strength development, especially in the normal class concrete.
Okay, and I noticed Evans included a link to the spotlight on myth busting. I think that's really important, because my observation is there's the perception of risk as well as the reality of risk.
Yeah.
Mehdi, as a contractor, we know Lendlease has gone hard with its ambitions and communicated that to the market. But you know, your colleagues who have got their jobs on the line to deliver a quality outcome, what are they saying? What are the red flags, potential red flags for them?
Yeah, it's like pretty much like, because we are going to change business as usual. So always there is some pushback across the industry. So how we are addressing there are two angles. One is, again, national concrete databases say this mix already been used in this job in Victoria. So they didn't have any problem. And we are leveraging CCA template. Literally, any concrete mix design delivered to the site, there is a one mixed unique ID, mechanical properties, shrinkage, desired strength, as well as global warming. So all data are going to capture and say, this has been used, no problem. And another part, I want to thank Ali and his team a couple of weeks ago at UNSW. Steve Foster mentioned about the TS199, which is to say, all right, a specification, like if we are using alkali activated, make sure put it in a specification so there is not any worry about, like, as long as satisfy a creep, future creep, tick the box, so we can use it. So again, it's a kind of the change management required, not at least across industry, but I believe the value of data. When we show data, we show this mix already been used, no problem. That convinces the project team. to implement that in their own project as well.
There's also a risk, sorry, just to add to that, in terms of the use of new materials. I noticed that someone in the chat has asked about lithium byproducts, for example, as a potential new area for supplementary cementitious materials, which I won't answer directly because there is some fantastic research in that space that's happening right now, but I probably can't confidently talk to it. But it does open a question of, you know, in terms of our infrastructure, when we're specifying them for a long period, so bridges for 100 years, roads for 40 years, buildings for 50 years, how do we demonstrate performance of these products over that long period, but very quickly? You know, if we want to launch a new product to market before the 2030, you know, first round targets, for example, certainly before 2050, when we're supposed to be as a country net zero, how do we get that rapid adoption of new products that haven't necessarily had the exposure testing, you know, that demonstrate that the bridge is going to last for 100 years? So I know Steve Foster will disagree with me, as he did at the last event that we ran together, but I think we do need to see innovation in terms of the accelerated aging testing methodologies that we have available as these new low carbon products come to market, so that we can demonstrate performance reasonably consistently over that long period.
Thanks, Claire. And MECLA is an environment that allows disagreement. So we're not all going to agree. There are no silver bullets. This is systems change. So many perspectives at the table. Hey, in the introduction, Evan, you mentioned it's not wise to specify a particular minimum SCM percentage. Someone in the questions quite rightly said, well, why not? How do you respond to that?
Yeah, thanks, Hudson. And why I didn't kind of go into, I think I'm still kind of going, but yeah, with SCM, I guess it's just the percentage of supplementary materials in relation to it. So it's just a ratio. So if you go, oh, Wholesome's 20% and like another company is 20%, they're not comparable numbers on a range of issues, because you could have the same amount of cement doing nothing and just add fly ash on top of it and call that 20% in comparison to a very low cement content. And then you've got the, you know, the 20% SCM as well. So that can be kind of gamed. And then in addition, every concrete company has different emissions for like their cement and their transport and their materials as well. So it's very superficial. It's at best like a proxy kind of thing. Like, and we really need to move away from it, because as I said before, like it doesn't send any incentive for decarbonizing the supply chain. Like, what incentive does that send to us for using renewable electricity or cement manufacturing using alternative fuels? It just, oh, they're all the same. It doesn't matter. And then in addition, like slag and fly ash have very differing emissions as well. Fly ash is straight out, very little kind of processing. It's just basically the transport onto it, depending on where you're sourcing it from. Slag actually requires further heating and grinding as well. So slag actually has an impact maybe like 5 times higher than fly ash as well. So if you just assume they're all the kind of same, you've got so many kind of things that are wrong about percentage SCM and using it for sustainability requirements. And it was never designed like that. It was designed for like durability and other kind of chemical kind of properties of it. So I guess we're in a new frontier of like trying to get reduced embodied carbon of concrete. So that's why we need to move to embodied carbon and EPD data.
Okay, so really have to be aware of oversimplifications that could send us down the wrong path. Hey, I'm looking at the time, and unfortunately, any conversation about reducing emissions, particularly low emission concrete, just time flies. So, and we are out of time. What I'd like to ask as a group, the chat has been, as always, is very very active, very engaged. If people have further questions, how can they approach the working group to learn more?
Yeah, for me, yeah, I'm keen. Kathy's going to take a copy of these questions, and I think as a working group, and this has been great, like feedback, I guess, from everyone as well. And then, yeah, as the concrete working group as well, we normally have a number of new members kind of coming each month as well, like to learn about knowledge and education with those monthly presentations and discussions. So if you're a member of MECLA, you know, you're welcome to kind of reach out and be an active participant in the working group as well. We don't want any kind of hangers on, like we want active kind of doers, as you say, Hudson, as well.
Yeah.
But also a big part of it as well is knowledge and education. Like, to get this right, everyone along the whole supply chain needs to have like knowledge about what low carbon concrete is and how to ask for it.
Okay, well, and if you're not a member yet, have a look at the website, sign up for our newsletter. A new edition went out this morning. So hot off the press information on this and all of our other doings. It's left for me now to say thank you very much. Ali Kashani, Evan Smith, Nikki Jackson, Claire Tubele, and Mehdi Rabati, thank you all for your time, and for your dedication to drive this and to make it happen. It is systems thinking. There's so many components to what's needed here. Really appreciate your commitment to this. And to our attendees, thank you very much for dialing in. To Kati and Alexi from our secretariat, and to Monica as ever. MECLA works because it's collaborative. So thank you for your contributions and collaboration, everybody. We'll see you again very soon. Thanks very much.